A platform architect is a technology professional responsible for designing, developing, and managing the platform infrastructure that supports the deployment, scaling, and maintenance of applications within an organization. The platform they manage is typically composed of various components, including cloud services, containerization solutions, orchestration tools, and shared services like monitoring, logging, and security. Their role is crucial in ensuring that the infrastructure and services are robust, scalable, and capable of supporting a wide range of applications. Below is a detailed explanation of their roles, responsibilities, and their involvement in the application development process, along with a comparison between a platform architect and a solution architect. 1. Roles and responsibilities of a platform architect. 1.1 Platform design and architecture. The platform architect designs and builds the foundational platform that hosts applications and services. This includes selecting technologies, defining infrastructure requirements, and creating architecture diagrams that depict platform components. Example, in a microservices environment, the platform architect might design a Kubernetes-based platform that supports containerized applications, ensuring it integrates with cloud services like OS or Azure for resource management. 1.2 Cloud and infrastructure management. They are responsible for designing and managing cloud infrastructure, for example, OS, Azure, GCP, or on-premises data centers that host applications. This includes creating architecture blueprints for virtual machines, storage solutions, networking, and disaster recovery setups. Example, setting up an OS environment with X2 instances, S3 storage, and virtual private cloud VPC configurations to host a scalable application infrastructure. 1.3 Platform services and automation. Platform architects design and implement services like continuous integration / continuous deployment, C/CD, pipelines, automated testing frameworks, and monitoring systems that support the development lifecycle. Example, designing a C/CD pipeline using Jenkins and Kubernetes to automate the deployment process, ensuring applications are deployed consistently across environments. 1.4 Scalability and performance optimization. They ensure the platform is built to scale according to demand and optimize performance. This includes setting up load balancers, auto-scaling groups, and distributed caching mechanisms. Example, configuring auto-scaling in a Kubernetes cluster to handle traffic spikes during peak usage periods, like sales events on an e-commerce platform. 1.5 Security and compliance. The architect embeds security measures into the platform, including identity and access management, IAM, encryption, firewall configurations, and compliance with regulations like GDPR, CTSS, or HIPAA. Example, implementing IAM policies on OS to control access to cloud resources and setting up monitoring tools to detect any suspicious activity. 1.6 Integration of monitoring and logging services. They integrate tools for monitoring platform health and logging application activity. This enables proactive monitoring and troubleshooting of platform or application issues. Example, setting up Prometheus and Grafana for monitoring application and platform metrics, and integrating Elk, Elasticsearch, Logstash, Kibana for logging and analytics. 1.7 Collaboration with development and operations teams. Platform architects work closely with development and operations teams to ensure that the platform supports application development, testing, and deployment efficiently. They often collaborate with DevOps engineers to implement infrastructure as code, ISE, using tools like Terraform. Example, designing a unified deployment platform that allows development teams to deploy applications using automated scripts, reducing manual setup and deployment times. 1.8 Documentation and platform governance. They document the platform architecture, policies, and best practices to ensure that all teams using the platform understand how to deploy and manage applications effectively. They also define platform governance rules. Example, creating a detailed architecture document for the platform that includes guidelines for deploying applications, security protocols, and disaster recovery procedures. 2. Key aspects of the application development process involvement. A platform architect is involved in various stages of the development and deployment process. 2.1 Infrastructure planning and design. In the planning phase, they design the architecture of the platform, ensuring it can support various application needs and integrate with existing systems. 2.2 Development support and C/CD implementation. They build and manage C/CD pipelines and development tools that facilitate faster and more efficient development, testing, and deployment of applications. 2.3 Deployment and scalability planning. The architect designs deployment strategies that include load balancing, auto-scaling, and container orchestration to ensure that applications are deployed efficiently and can scale based on demand. 2.4 Security and monitoring integration. They set up security measures and monitoring systems, ensuring the platform remains secure and reliable, while providing visibility into the performance of applications. 2.5 Maintenance and optimization. Platform architects are responsible for ongoing maintenance, optimization, and scaling of the platform, ensuring it continues to meet business requirements and performance standards. 3. Difference between a platform architect and a solution architect. Aspect: Platform architect, solution architect. Scope focuses on designing and managing the platform infrastructure that supports the deployment and scaling of multiple applications. focuses on designing specific solutions that solve business problems, often involving multiple applications, services, and integrations. Technology selection chooses technologies for platform infrastructure, such as cloud services, container orchestration, and C/CD tools. Selects technologies for building the solution itself, including specific applications, databases, APIs, and integrations. Integration-focused designs platform-level integrations, such as service mesh, networking, and platform-wide services, for example, monitoring. Designs application-level integrations, like integrating third-party services or creating custom APIs to connect different systems. Scalability ensures that the platform is scalable and can support multiple applications with varying loads and requirements. Ensures that specific solutions are scalable and meet business needs, often focusing on scaling specific applications or services. Security focuses on platform security, including infrastructure protection, IAM policies, and compliance standards across all applications. Focuses on the security of specific solutions, ensuring secure data handling, API security, and compliance with specific regulations for those solutions. Documentation documents the platform architecture, including infrastructure components, shared services, and platform-wide policies. Documents solution architecture, including system interactions, workflows, and application-level integrations. Stakeholder collaboration collaborates with development, DevOps, and operations teams to ensure the platform meets technical and business requirements. Collaborates with business stakeholders, development teams, and IT managers to align the solution with business objectives and requirements. Example: designing a Kubernetes-based platform that hosts multiple microservices and supports their scaling, monitoring, and security. Designing a solution for a CRM system that integrates customer data from multiple sources and offers analytics capabilities. Summary: a platform architect is responsible for designing and managing the platform infrastructure that supports multiple applications and services across an organization, focusing on scalability, security, and efficiency. In contrast, a solution architect focuses on designing solutions that solve specific business problems, involving a broader scope that may integrate various applications and services. While the platform architect ensures that the technical foundation is robust, the solution architect ensures that individual solutions align with business needs and technical capabilities.